Welcome to the Deep Dive, your shortcut to being truly well-informed. Generative AI is, well, it's rapidly transforming just about everything. It's powerful, it's already changing how we work and live. But with that incredible potential comes a new class of operational risks. They're often overlooked. We're talking about things like AI, making up facts, hallucinations, or even displaying unexpected biases, things you wouldn't typically see in traditional software. So today, our deep dive is all about AI observability and generative AI systems. We're going to unpack why having true visibility into these complex systems isn't just a nice to have, but absolutely essential for anyone building or deploying these AI products.
That's exactly right. Our mission today is to, well, truly understand why the methods we've traditionally used to monitor software simply fall short for GenAI. We'll explore the unique risks involved, detail what crucial new metrics we actually need to track now, dive into the architecture of a robust observability stack, and touch upon the strategic decisions leaders face. We'll even glimpse into the future of this field because it's moving so fast. Our goal is really to give you the nuggets of knowledge you need to be truly well-informed.
Okay, so let's start by framing the core problem here. We all know traditional software, it tends to behave predictably, right?
Yeah.
Same input, same output, generally speaking. But large language models, LLMs, they're fundamentally probabilistic. The same exact input can lead to many different outputs, sometimes all of them technically valid. So if the output can be different every time, how do we even begin to track its health? It sounds, well, like trying to monitor a cloud. What's the fundamental shift we need in our mindset?
It's a huge shift, yeah. It's a seismic shift, really. And it's why we need to clearly differentiate traditional monitoring from true observability for GenAI. We're all familiar with traditional monitoring, that reactive checklist approach for known unknowns.
Like, is the server up or did the database connect, that kind of thing?
Exactly. It's designed to alert you when anticipated problems happen. You set thresholds, and if they're crossed, an alarm goes off. Simple enough. But for GenAI, that predictable world is just gone. GenAI Observability, on the other hand, it's a proactive, investigative discipline. It's about inferring a system's internal state from its external outputs. It's about asking deeper questions like why and how the system is behaving a certain way. And this is absolutely crucial for uncovering those unknown unknowns, the novel, unanticipated failure modes that are incredibly common with these probabilistic GenAI models. It's about understanding what's happening before it potentially becomes a crisis.
That makes a lot of sense. But then we hit the black box conundrum. We can control the inputs, we can observe the outputs, but that reasoning process inside the LLM itself is often completely opaque. It's like looking at a magic trick and only seeing the setup and the reveal, not how the rabbit actually got into the hat. So if we can't truly explain why it did something, does observability at least give us a better chance to predict when it might do something undesirable?
Precisely, and that's a really important clarification to make. Observability tools do not solve AI explainability, XAI. They can't, for instance, tell you the exact human understandable chain of thought that led to a specific hallucination. Not yet, anyway. Instead, they kind of work around that limitation. They do it by creating a high-fidelity, really comprehensive record of everything that goes in and comes out, plus all the context of the interaction. The goal, then, is to identify patterns that lead to undesirable outcomes by correlating all this data. And the implications of this opacity in GenAI are severe. I mean, undetected anomalies can quickly cascade into unpredictable, potentially harmful behaviors.
Which could lead to huge financial, reputational, or even legal consequences for organizations.
Exactly. Huge consequences.
Okay, so this brings us to a fundamental shift in how we think about the pillars of observability. Traditionally, it's built on what's known as MELT. That's metrics, events, logs, and traces. But for GenAI, we're really expanding these pillars, aren't we? It's not just the same old MELT.
Absolutely. We need to adapt and expand them significantly. So for metrics, yeah, we're moving beyond traditional CPU or latency. Those are still important, but we need AI-specific signals. Think token usage, that's a direct line to your budget right there. Or things like factual consistency, which is a totally new class of metric telling us if the AI is, hallucinating.
Right. That's a huge one.
It is. And this isn't just an addition, it's a fundamental shift in what we monitor. Events now include things beyond just simple errors, maybe model version updates, or a user flagging a response as harmful, or alerts for potential PII leaks. Much richer. With logs, we're moving from plain text, which is hard to analyze, to highly structured, context-rich JSON objects. A single log entry for an LLM interaction should ideally contain the input prompt, the model's response, any retrieval augmented generation or RAG context used, and all that metadata like user IDs and trace IDs.
So much more detail.
Much more detail. And finally, traces. These become paramount. For complex LLM applications, think chains or agentic workflows involving multiple calls traces, stitch all these operations together. They give you that end-to-end view for debugging and understanding the full journey of a request.
Okay, so what does this all mean for you, the listener, or your organization? I mean, why should you invest in this complex sounding system? What's the real business case for adopting GenAI observability?
Well, think of it less as just another cost center and more as your strategic shield, or maybe your compass. If trust is the currency of AI, observability is kind of like your mint.
I like that analogy.
Yeah, so first, it's about building and maintaining user trust. That means detecting and correcting inconsistencies, hallucinations, biased outputs before they erode that trust. Second, it ensures product reliability and performance, giving you clear signals on things like latency, throughput, making sure the user experience is good. Third, and this is critical, it helps you mitigate risk and ensure compliance. Being able to proactively detect harmful content or PII leaks or biased outputs is absolutely crucial for adhering to regulations like the EU AI Act or GDPR.
Right, the regulatory landscape is evolving fast.
Exactly. And finally, it drives operational efficiency and cost management. By reducing the mean time to resolution, MTTR, for issues, you free up valuable engineering resources. And importantly, you prevent those runaway token costs, which can quietly drain your budget.
Okay, that makes sense. Now let's talk specifics about the dangers. GenAI introduces this whole new, multifaceted risk landscape in production, moving far beyond traditional software concerns. What are the big ones we really need to be aware of?
Yeah, there are several key areas we need to break down. First, there's model performance and quality degradation. This is a big bucket. It includes things like hallucinations and factual inaccuracy. These are those really critical failure modes where the AI generates plausible but completely incorrect or ungrounded outputs.
Stuff that sounds right but isn't.
Precisely. It erodes trust and can even spread misinformation actively. Then there's drift, which is kind of a silent killer. You've got data drift when the input data it sees in production changes over time. Concept drift is when the underlying relationship between inputs and outputs evolves. And model drift is the result. The model's performance just degrades over time.
And it can happen subtly, right?
Yeah.
Without big warning signs.
Very subtly, until suddenly performance tanks. Finally, for performance, we also have the usual suspects, but amplified. Performance bottlenecks specific to LM inference. Latency is a big one for user experience, throughput for scalability, and resource consumption, which drives up operational costs. The second major category is ethical, safety, and security risks. This is huge. LLMs can perpetuate bias and fairness issues. They can amplify existing societal biases if you're not monitoring carefully. Think about a recruiting AI showing disparate impact against certain groups.
Yeah, that's a major concern.
Definitely. Then there's the risk of toxicity and harmful content generation. You need real-time detection and filtering for offensive or unsafe stuff. And new security vulnerabilities emerge too. Things like prompt injection, where malicious prompts trick the model into doing something unintended.
Like revealing secrets or ignoring safety rules.
Exactly. Also, data leakage, inadvertently exposing sensitive PII, and even denial of service, or just massive cost overruns from computationally expensive, malicious prompts.
And beyond those immediate dangers, there's a pretty significant operational and financial side to these challenges too, isn't there? The sheer scale of GenAI must make these issues even harder to manage.
It absolutely does. Cost management is huge. Many powerful foundation models you pay per token. Every input, every output has a direct cost.
So you need meticulous monitoring just to avoid breaking the bank.
You really do. Otherwise, budgets can just evaporate. Then there's scalability and architectural complexity. Production GenAI applications are often these complex distributed systems chains, RAG pipelines, agents interacting. End-to-end tracing becomes absolutely paramount for debugging those. And lastly, many organizations face infrastructure and data readiness issues. If you already have weaknesses in your data infrastructure or maybe a skills gap, those problems can seriously exacerbate GenAI challenges. Observability becomes even more critical then for identifying and diagnosing those underlying problems.
What's really fascinating here, as you describe it, is how interconnected these risks seem to be. It's not just one isolated problem pops up. It's more like a web, where one issue can quickly trigger another.
Exactly. That's a great way to put it. Imagine data drift starts happening. That leads to more hallucinations. Then maybe those hallucinations disproportionately affect a certain demographic group, which suddenly becomes a bias issue.
Which then erodes user trust for that group.
Precisely. It cascades. And this complexity necessitates a cross-functional approach. We talk about LLM ops or GenAI ops. It's not just the engineers and data scientists anymore. Product managers, legal teams, security teams, they all need a unified view. And observability provides that shared source of truth to understand and manage these interconnected risks collaboratively.
Okay, so we know why we need it. We understand the risks, the what. Now, the million-dollar question, maybe literally, how do we actually measure these new risks? You mentioned traditional ML metrics often fall short for generative models because there's often no single ground truth answer to compare against. So what do we do?
Yeah, that's the challenge. It requires a multi-dimensional approach to measurement. We need a really comprehensive framework of metrics and evaluations. So for operational health, sure, we track classic metrics like latency and throughput. Those still matter. For cost and resource utilization, it's things like token usage per request, or maybe cost per query or per user session. But then we get into the newer stuff. For output quality and faithfulness, we're looking at things like groundedness or factual consistency, basically, measures to fight hallucinations. Also, relevance, coherence. Does the output make sense and answer the question?
Okay.
Then for model behavior and drift, we use metrics like perplexity, which is essentially how surprised the model is by new data. A rising perplexity can indicate drift. We also have specific data concept drift scores and output stability measures. Critically, for security, safety, and ethics, we need things like toxicity scores, PII detection rates, flags for potential prompt injection attempts, and specific bias metrics like disparate impact analysis.
Right, measuring fairness directly.
Exactly. And finally, for user experience and engagement, we track things like user satisfaction scores, maybe from feedback buttons, task success rates, and escalation rates to human support.
I can see how we track latency or token usage. That's straightforward counting. But how on earth do you put a number on factual consistency or bias? That seems like a monumental challenge qualitatively. What are the specialized techniques required for those?
It's definitely not a simple count. It's more complex. We employ several methodologies. First, you have heuristic and rule-based evaluations. These are often simple and fast. Things like flagging specific forbidden words or using enneagram overlap metrics like ELEU or Roche scores, which compare generated text to reference text.
But they can be a bit brittle,
Yeah.
right? Easily fooled.
Exactly. They're often brittle, but good for quick real-time checks. Then we have something more powerful, model-based evaluations, or LLM as a judge. This is a really interesting technique where you use a capable LLM, maybe like GPT-4, to actually evaluate the output of your production model against specific criteria you define. It approximates human judgment, but scalably.
Using an AI to judge another AI.
That's the idea. Then there are semantic and embedding-based evaluations, these leverage vector embeddings. You convert text into numerical vectors, these embeddings capture meaning, and then you use metrics like cosine similarity or BERT score to understand semantic meaning and check for things like relevance or semantic consistency between prompt and response, or with RAG context. And finally, the gold standard, though it's the least scalable, is human-in-the-loop HITL feedback. This could be explicit user feedback, like thumbs-up-down buttons or detailed annotation by expert reviewers. This human feedback is crucial for auditing and calibrating the automated systems.
So it really sounds like a hybrid strategy. Maybe combining these approaches in layers would be the most powerful for real-world scenarios.
Absolutely. A funnel approach often works best. Maybe all responses first pass through some fast, real-time heuristic checks. Then, a sample, or maybe responses flagged as potentially problematic, go to an automated LLM as a judge for a deeper analysis based on your criteria. And finally, a small, curated sample, especially where the production model and the judge AI disagree, gets routed to human reviewers for that definitive judgment.
And that human feedback then improves the judge AI.
Exactly. Crucially, this human feedback continuously improves the automated judge over time, making your whole automated evaluation system smarter and more aligned with what you actually care about.
Okay, with the why and the what pretty clear now, let's turn our attention to the how, the actual technical architecture behind building a robust GenAI observability system. What does that blueprint look like?
Yeah, let's get into the nuts and bolts. At a high level, it's an end-to-end observability pipeline. It typically starts with data collection and instrumentation.
Capturing the signals.
Right. Then moving to data processing and aggregation, then storage and querying, followed by analysis, visualization, and alerting, and finally, ideally, action and remediation. It's a full loop.
Let's focus on that critical first step, instrumentation.
Yeah.
How do we actually capture all this new, rich data from these complex GenAI systems?
This is where you use SDKs, software development kits, and agents. These are pieces of code that run within your applications, your infrastructure, and interact with the AI models themselves to collect that telemetry data, the metrics, logs, traces. And a pivotal strategic decision here, really important, is adopting open telemetry, or OTel.
Ah, yes, OTel comes up a lot.
It does, because it's a vendor-neutral open source standard for generating, collecting, and exporting telemetry data. This is critical for avoiding vendor lock-in.
So you're not stuck with one monitoring provider forever.
Exactly. And it future-proofs your systems. It allows you to potentially switch observability platform vendors down the line without having to completely re-instrument your entire code base, which is a massive undertaking.
Okay, that makes sense strategically. And once that data is collected via OTel or other agents, how do we process and store it effectively to make it actually useful? It must be a lot of data.
Oh, it's a huge amount of data. For processing, you often need a hybrid approach. You need both real-time streaming for immediate alerts on critical issues and batch architectures for doing deep historical analysis, maybe for drift detection over weeks or months. And crucially, as we mentioned, logs must move from just plain text strings to highly structured, context-rich JSON objects. This makes them easily queryable and turns them into rich, analyzable data sets, not just text dumps. There's also an emerging trend, I should mention, AI-powered log management, using AI itself to sift through the sheer volume of logs.
Using AI to understand the logs from AI systems.
Exactly. To automatically identify patterns or anomalies that humans might miss, freeing up engineers to focus on the root causes rather than just searching through logs. Now, for storage, it's definitely a polyglot requirement. You need different types of databases working together. You'll use time series databases, TSDBs, think Prometheus, InfluxDB for those numerical time-stamped metrics like latency, token counts, CPU usage. Then, vector databases. These are a crucial and somewhat unique component for GenAI observability.
Because of the embeddings, right?
Precisely. Storing those embeddings of prompts, responses, maybe arg chunks. This allows for semantic analysis, things like finding similar problematic prompts, checking if the arg context retrieved was actually relevant to the query, or detecting subtle semantic drift over time. And the future trend, many believe, points towards a centralized observability data lake, storing all the raw telemetry logs, metrics, traces, maybe even embeddings in a low-cost open format like Amazon S3 with something like Apache Iceberg on top.
Breaking down the data silos between metrics, logs, traces.
Exactly. Breaking silos, enabling powerful cross-domain analysis. The key ability here is to correlate data across these disparate stores. Imagine linking a latency spike you see in your TSDB to the detailed logs and traces in your data lake for that exact moment, and then maybe using a prompt from that log for a semantic similarity search in your vector database to find related issues. That's powerful.
So, with all this data being collected, processed, stored in these different systems, how are the insights actually derived and shared? How do we visualize this mountain of data and, importantly, get actionable alerts?
Yeah, visualization and alerting are key to making it useful. Effective dashboards need to be tailored to different personas. Leadership might want high-level KPIs on cost, user trust, overall quality.
Yeah.
Developer or SRE dashboards need real-time operational health, latency, error rates. Data scientists need dashboards focused on model quality, drift metrics, evaluation results.
So not one size fits all.
Definitely not. And they need to be interactive, allowing drill downs from a high-level alert right down to the specific traces or logs. For intelligent alerting, we need to move beyond just simple static thresholds like alert if latency 500 meters. We need anomaly detection that learns normal patterns, multi-level severity alerts, and critically, we need quality-based alerting for those GenAI-specific issues we talked about. Alert if the hallucination rate exceeds X%, or if the average toxicity score spikes, or if bias metrics cross a certain threshold.
Alerts based on the quality of the AI's output, not just its speed.
Exactly. And the ultimate goal then is robust root cause analysis, RCA, and ideally automated remediation. Tracing, as we said, is probably the single most powerful tool for RCA in these complex distributed GenAI apps. Visualizing that entire request lifecycle helps you pinpoint bottlenecks or where errors originated, say, in a complex RH pipeline. We're also seeing the rise of AI-assisted RCA. Using LLMs again, this time to analyze incident data logs, traces, alerts to suggest probable root causes, and maybe even remediation steps to the engineers.
Interesting. Helping debug the system that generated the logs.
It's getting quite meta. And the ultimate goal for many is automated remediation, creating self-healing systems where alerts don't just notify a human, but automatically trigger workflows to resolve issues, maybe temporarily block a malicious user, automatically revert a problematic prompt template, or trigger a model retraining pipeline if significant drift is detected.
Okay, that covers the technical side really well. Now, let's maybe zoom out a bit and transition from the technical implementation to the high-level strategic decisions for leadership. The build versus buy question is always huge in tech, especially for platform capabilities. For something as complex and evolving as GenAI observability, what's the pragmatic approach here?
Yeah, that's a critical decision. For GenAI observability specifically, I'd argue that buying a managed platform, whether that's a commercial vendor solution or maybe a managed open source offering, is almost always the pragmatic default choice for most organizations. Building a full-featured, scalable, and reliable observability platform in-house is just a massive engineering undertaking. It requires specialized expertise, ongoing maintenance. It's often a strategic error when so many mature solutions already exist.
So focus your internal resources elsewhere.
Generally, yes. Building should really only be reserved for components that are truly core business differentiators, something providing a unique competitive advantage that you can't get off the shelf.
Yeah.
Maybe a highly domain-specific evaluation metric or a bespoke integration. But the core platform, probably better to buy.
But as always, the true cost isn't just the sticker price of that platform license, is it? We need to think broader.
Absolutely not. You have to consider the total cost of ownership, TCO. This includes the software or subscription costs, yes, but also potentially massive infrastructure costs for storing and processing all that telemetry data we talked about. That can be significant. And crucially, there are the often underestimated personnel costs. You need engineers, MLOps folks, data scientists, not just to implement the platform, but to maintain it, and most importantly, to analyze the data and derive insights. So a platform that seems more expensive upfront might actually have a lower TCO if it significantly reduces your infrastructure burden or the personnel time needed for analysis through better automation or user experience. You have to look at the whole picture.
That's a really important point. This raises another important question. Beyond just the technical and financial aspects, how does all of this observability work tie into the broader concepts of responsible AI and AI governance? Is there a direct link?
Oh, a very direct link. Observability is arguably the primary mechanism for actually implementing and enforcing AI governance in practice. It's how you translate abstract, responsible AI principles like fairness or transparency into measurable metrics that you can continuously monitor. You track bias metrics to enforce fairness. You record inputs and outputs for accountability. It's also essential for ensuring compliance and auditability. Having immutable, time-stamped records of model behavior, decisions, inputs, outputs, that's crucial for regulations like the EU AI Act. Observability provides that audit trail.
It makes governance concrete.
Exactly. It makes it real and actionable. And it's key to building a culture of accountability across the organization. By providing that shared source of truth we mentioned earlier, it enables that cross-functional collaboration between tech teams, legal, risk, product, all focused on responsible AI development and deployment. It's how you put policy into practice day to day.
So looking ahead now, what does the future hold for GenAI observability? Where is this all heading in the next, say, 3 to 5 years? It feels like it's evolving incredibly quickly.
It really is. I think we're moving rapidly from reactive monitoring what broke towards predictive monitoring, using AI itself to forecast potential issues. Imagine AI forecasting model drift before it significantly impacts users, or predicting future resource needs based on usage patterns, or even identifying high-risk inputs before they're sent to the model, allowing for proactive intervention.
So getting ahead of the problems.
Getting ahead of them. We're also definitely closing the loop more and more with automated remediation and self-healing systems, transforming observability from just a system of insight into a true system of action that actively maintains system health. We'll also see an increasing role for explainable AI, XAI techniques being integrated into observability platforms, not necessarily solving the full black box problem, but providing better insights into why a model made a particular decision.
Like highlighting which words in the prompt most influence the output.
Exactly, or identifying which documents retrieved by a RAG system were most influential in generating a particular answer, providing more debugging clues. And ultimately, I think the longer-term future is heading towards self-observing systems, where AI systems become increasingly capable of monitoring their own behavior, diagnosing issues, and perhaps even adapting or correcting themselves. AI monitoring AI.
Wow.
Yeah, it leads to ideas of recursive improvement, but it also introduces, new complexities around how you then monitor the monitoring system itself. But it's a clear sign of the field's rapid maturation.
So the key takeaway then from our deep dive today seems pretty clear. GenAI observability isn't just some technical tool or an optional add-on. It's really a foundational strategic enabler. It's essential for building trustworthy, scalable, and reliable AI products. It seems like it's how you actually unlock the full potential of GenAI responsibly.
I think that sums it up perfectly. It's foundational.
Which leaves us with a final, maybe provocative thought for you, the listener. As these AI systems increasingly gain the ability to monitor, analyze, and even heal themselves, what new forms of human oversight or maybe different organizational structures will we need to develop? How do we ensure we truly understand and can effectively guide these incredibly powerful creations, even as they become more autonomous? Something to think about. We certainly encourage you to consider how these insights might apply to your own work, or simply to keep exploring this really exciting and fast-moving frontier of AI observability.